On the Smart Columbus automated shuttle pilot. We can get started now. Thank you all for joining us today. I'm Katie McLaughlin. I'm based in the Detroit, Michigan office in WSP USA's Connected and Automated Vehicles group. We also have Tom Chimcho on the line to help answer questions at the end. He's based in the Columbus, Ohio office, and he's WSP's project manager for the Smart Columbus project. I'm just going to go over a few general housekeeping items before we get started. So the plan is to go through a presentation for about 15 minutes and then to save the rest of the time for questions. So if you have any questions during the presentation, please type them into the question box as I go along. And secondly, there's a PDF of these slides also available in the handout box for you to download and review whenever you would like to. Okay, so one of the things our Connected and Automated Vehicles group does is work on pilot projects. These projects help to demonstrate the challenges, opportunities, and implications of connected and automated vehicle technologies in the real world. So I'm going to talk about one of those projects today, which is an automated shuttle project that is part of the Smart Columbus program. So I just wanted to start with how this project originated. As many of you have probably noticed from similar webinars to this one, in the past few years, there have been many disruptions that are happening at the intersection of transportation, technology, and data. The United States Department of Transportation also noticed this trend, and they saw it as an opportunity to encourage US cities to think differently about how they could manage this time of change. This led to, among other things, a grant program that was known as the Smart City Challenge. 78 mid-sized American cities applied for this grant program, and the city of Columbus, Ohio was fortunate enough to be named the winner. Through this program, the city's vision has been to empower residents to live their best lives through responsive, innovative, and safe mobility solutions. Since August 2016, WSP has been supporting 2 of the projects in the Smart Columbus portfolio as the technical lead. The topic of today's webinar is the project officially known as the Connected Electric Autonomous Vehicles, or CEAV project. A webinar on the Connected Vehicle Environment project will also be happening in a couple weeks on June 25th at 11 a.m. Eastern Time, if you're interested. So from the beginning, Columbus had planned to deploy automated shuttles to enhance public transportation connections in the city. I just wanted to start by providing a refresher on what automated shuttles are and why cities like Columbus are interested in them. Automated shuttles, which are sometimes called AV shuttles, they're vehicles that are similar in size to existing shuttle vehicles, such as parking shuttles that you might see at an airport. They generally have a capacity of about 5 to 20 passengers, and they operate at low speeds on surface streets rather than freeways. Most are also electric vehicles. These vehicles are operating on fixed, predefined routes in a controlled environment that eliminates many of the remaining challenges of autonomy. So on a scale of 0 to 5, as defined by the Society of Automotive Engineers, most people would consider this to be a level 3 or 4 of driving automation. This is a limited type of operation, but it's of interest to us and to many cities like Columbus because it's something that's possible today. So I've included 6 examples of automated shuttles on this slide, but just wanted to note that new products could come to or leave the market at any moment. Many companies are working hard behind closed doors to generate a larger splash when they do launch their product. And some companies have had trouble developing sustainable business models and have had to leave the market. So Columbus's grant application proposed deploying automated shuttles in what was then referred to as the commercial district, Easton Town Center. The vision was to deploy a fleet of 6 vehicles across 3 fixed routes in a live mixed-use traffic environment where they would interact with other vehicles, bicyclists, pedestrians, and other forms of transportation. They would be operating in an environment that included both signalized and non-signalized intersections. In particular, the intent with this plan was to connect a transit center north of Morse Road, which is a major road in the area, to the employment and entertainment opportunities south of Morse Road. This vision of multimodal connectivity is represented by the rendering shown on this slide. After many hours spent working towards this vision, it became more and more apparent that it just wasn't feasible given both current travel behavior and current automated vehicle capabilities, in particular to safely cross Morse Road. And so eventually the decision was made to pivot to a different approach. This leads me to our first major lesson learned from the Smart Columbus Automated Shuttle project. As the project team continued to face roadblocks and challenges with the plan as it was laid out in the grant application, we decided to ground ourselves back in the actual goals of the project and why this was something Columbus wanted to do. So what the city wanted to do was help residents by connecting the community to the jobs and services they needed when they need them. They wanted to improve the safety and mobility of travelers. They wanted to encourage public transit use, and they wanted to reduce traffic congestion and any related externalities. While there may have been a situation in which meeting these goals could have been possible at Easton, it seemed very unlikely that that would be the case during the 4-year grant period. The city therefore decided that it was more important to them to pursue a solution that could really help people and be feasible rather than forcing an opportunity that just wasn't the right fit. So the city received approval to do so, and they began the process of hosting workshops with members of the community to determine which of the many candidate locations would be the most beneficial and feasible. We supported the city during this time by helping craft and release a request for information for vendor feedback on the proposed routes and use cases. Meanwhile, the State Department of Transportation stepped in to support an additional deployment, which eventually led to a new plan, a series of 2 deployments in 2 different locations in Columbus that would help both the city and the state learn more and integrate these learnings during the course of the project. So here I have graphics of the 2 routes. The first route was known as the Smart Circuit, and it traveled in a loop adjacent to downtown Columbus. It served the Smart Columbus Experience Center, where many Smart Columbus staff have their offices, Bicentennial Park, COSI, which is the Center of Science and Industry, and the National Veterans Museum. The main goal of this route was to expose residents and visitors to this new technology and to help people move between these attractions. The second route was known as the Linden Leap, and it travels between St. Stephen's Community Center and the Linden Transit Center, both of which are designated as smart mobility hubs within the Smart Columbus portfolio, which helps tie this project into other program goals. The main goal of this route was to connect the St. Stephen's Community Center with a high-frequency bus rapid transit line at the Linden Transit Center, as well as to enable connections within the neighboring community. The first RFP, the first deployment was awarded through an RFP process to Bay Mobility, whose vehicle holds 6 passengers, including a safety operator, and is shown on this slide. The second deployment was awarded through a second procurement to Easy Mile, who offers a vehicle with a larger capacity of around 12 people, including the safety operator, and it has space for both seated and standing passengers, as well as space in a deployable ramp for a wheelchair. Both vehicles are shown here on their routes. The May Mobility pilot ran from September 2018 to September 2019, and the Easy Mile pilot launched its 1-year run this February. So while working through these deployments, a key lesson that we learned from the first was that procurement documents and contracts could be significantly improved, especially around data requirements for the second. Building upon this first deployment, in the second procurement, we sought to fully define the data sets, methods of transmission, and frequency of the data to ensure we met our performance measurement goals for the project. This has allowed the city to get the information it needs in a format that can be used to eventually evaluate the success of the pilot. Another key learning is around communication about connected vehicle capabilities. So one of the letters in the CEAV acronym is connected, and thus connectivity is an important component that's core to the goals of this project. So as a refresher, a connected vehicle is any vehicle that is equipped with some sort of wireless communication device that allows it to share information with other vehicles and objects on the roadway. CVs can be automated, but AVs are not necessarily connected. And while automated vehicles are expected to improve vehicle safety by limiting the impact of human error, it's expected that with connectivity, additional safety benefits of automated driving systems could be realized because this would allow vehicles to gain context beyond what a regular driver would know or would be able to see visually. So the first RFP offered proposers the option to use connected vehicle technology that was being installed as part of a vendor connected vehicle demonstration at the signalized intersections along the first route. However, it turned out that the vendor would be using its own proprietary technology that is different from the connected vehicle technology that the city was more familiar with. And this led to some challenges installing this additional infrastructure, and it also removed the possibility of testing integration with an existing system. So the second vendor has allowed their vehicle to be connected to Smart Columbus's connected vehicle environment in a way that has allowed other connected vehicles to benefit from the information that the automated shuttle provides, but the AV system will not yet be using the connected vehicle information in any way. It's really just more for demonstration purposes. However, as will be discussed in the future webinar I mentioned earlier, the connected vehicle environment is on an independent schedule from this project, and it has not yet been deployed. However, once it's fully deployed, this integration will take place. So another insight we've had while working through this project is experiencing firsthand the trade-offs that are necessary when striving to comply with sometimes contradictory regulation in this quickly evolving space. For example, the intent of this project was to meet Buy America requirements, which specify that a certain portion of federally funded projects be made in the US, Americans with Disabilities Act, or ADA requirements, which enable services to be accessible to people with varying needs and abilities, and then Federal Motor Vehicle Safety Standards, or FMVSS, which place requirements on the structural integrity and other safety features of vehicles. However, automated vehicles that are large enough to have space for a wheelchair and other features for ADA accessibility typically do not have standard driving amenities, such as steering wheels, mirrors, and pedals, because they've been designed from the ground up as automated vehicles. There is, however, an exemption process to get a vehicle like this approved to operate on public roadways, but this exemption only applies to imported vehicles, not those that are produced domestically, so then these vehicles do not meet Buy America requirements. Likewise, there are automated vehicles of a smaller size that are basically modified existing vehicles that comply with both Buy America and the FMVSS requirements, but they're not ADA accessible. So decisions have to be made here on what can be included in a pilot that is being conducted while technology is still being developed, and what is important but may need to wait for a longer term deployment to be fully realized. So for our last insight, as you may have heard, on February 20th, a Linden Leap shuttle was traveling at about 7 miles per hour and it made a sudden stop. As a result, one of the two passengers on board slipped from her seat onto the floor and she sought medical attention as a result. Smart Columbus immediately stopped service of both shuttles until the cause of the sudden stop could be determined. Easy Mile arrived on site a few days later to review the vehicles, and then on February 25th, the Federal National Highway Traffic Safety Administration, or NHTSA, called for the suspension of passenger service for all US-based Easy Mile shuttles, pending a safety evaluation. Smart Columbus's statement on the matter is that the Linden Leap won't return to service until NHTSA clears the vehicle and the City of Columbus is satisfied with the resolution of a technical and safety review. And that sort of leads us to today. At this point, both the city and NHTSA have performed their analyses and laid out certain mitigation actions that need to be adopted by the vendor before passenger service can resume. However, these steps cannot begin right now due to travel restrictions and other challenges associated with the COVID-19 pandemic. In March, the vehicles were still operating without passengers for some time, sort of to do some testing and training of operators. But at this point, the vehicles are not in service and the project is essentially on pause with the vehicles safely stored in the garage. Even if service were permitted and if it were considered essential, these shuttles are quite small and likely would not be able to allow social distancing at their current configuration, which usually has an operator standing in the middle and the passengers sitting around all in the same cabin. In some other pilot deployments in other parts of the US, project teams have been exploring ways that they can help during this time, such as allowing vehicles to operate without a human operator on board to transport cargo. So for example, this can be completed tests and other medical equipment within a hospital campus. Because this technology is still under development, this hasn't been a widespread solution, but it will likely add interesting considerations for AV providers to add to their list of potential use cases and benefits of the technology going forward. It's something that we're beginning to explore in Columbus because the vehicles are permitted to operate as long as they don't have any passengers on board right now. So overall, while this multi-year project hasn't always gone exactly to plan. It's still been a very valuable experience for those of us who have had the opportunity to be involved, as well as the city and its residents. So at a high level, it has demonstrated the ability for automated shuttles to operate on predefined routes, subject to certain constraints and limitations. It has shown that if implemented correctly, a pilot can help a transportation provider enhance their network and show that they're willing to innovate. And it can also help the public become more comfortable with autonomous vehicle technology. However, just as with any other transportation service, it's important to ensure deployment is responsive to local stakeholder needs and constraints. So that's all I have in terms of slides for today. I hope that was informative. We have some time for questions now. So if you have any questions for Tom or me, you can continue typing them into the chat box. I think we've already had some questions come in.
Yes, thank you, Katie, for your presentation. So before moving into the Q&A, I would like to remind attendees that they can download a PDF version of the presentation from the handout box on the dashboard. So let's go to the first question. Based on the experience of operating the shuttle, what other use cases for this technology would you think are feasible?
That's a good question because as I showed through these slides, we sort of were at first pursuing a use case that wasn't quite feasible. I think these fixed repeatable routes are a good environment, especially if it's sort of on a BRT route where you have separated infrastructure for the automated vehicles. That would be ideal. But they are somewhat capable of operating in some types of mixed traffic. And then another use case that I'd like to see explored more is freight and cargo, particularly if it were sort of in a warehousing or maybe an airport environment.
Thank you. Next question. What was a safety case developed for the 2 real-world deployments? If so, who developed it and who accepted or approved it?
Okay. So I guess to start off with, for both of these procurements, the city looked for like a turnkey solution where the vendor would just be providing their vehicles as a service and retaining all the liability for it. However, the city wanted to make sure that what these vendors were promising was possible and safe. So one of the things we helped provide was a test plan. And maybe Tom can talk more about that, but in general, the idea behind the test plan was to lay out certain cases and scenarios that the vehicles should be able to do. And then we had a testing process where we sat in these vehicles for a couple hours and just drove around and made sure everything was good and safe.
Yeah, so to add what Katie's saying, I said the test plan was one of the foundations of what we were doing, but also the city had a safety management plan that was put in place for the broader Smart Columbus program, which included the element of the automated vehicles. That was reviewed by not only our team, but the city team, as well as some outside providers that were involved in safety type of applications. I'm not sure if the term safety case was directly applicable here. There was not a third-party safety evaluation done as might be done on a light rail or something of that sort. So there was some dependency on the vendor being able to demonstrate, their experience and they having successfully deployed this in the field in the past.
Thank you. Next question. Could you comment more specifically on the issues with the initial Eastern Town Center plan? Sorry.
Yeah, so there were basically 2 sets of issues there. One was on the demand side. So we ended up doing an intercept survey of people who are currently taking transit to that area. And it turned out that a lot of the routes that served the transit center that we were hoping to provide first last mile connections to, they also sort of after going to that transit center went into the town center as well. So there wasn't as much demand for first last mile service as we originally thought, especially at the headways we'd be able to provide. And then I guess the second set of issues was related to the technology. This was actually was it maybe 2-3 years ago that we made the pivot. And so there's been some improvements since then, but even now, I guess one of the biggest issues was Morse Road. I think it has a 45 mile per hour speed limit. So even if the vehicles had a dedicated signal phase going across that road, it wasn't something that would necessarily be safe to do. And then also within the town center, the roads had relatively high speed limits, and these vehicles generally travel at around 12 miles per hour. So even something on the 30 mile per hour scale could be a bit fast for mixed traffic.
Thank you. Next question. Are there KPIs associated with each of the shuttle routes? If so, how were they developed and how were they measured?
Yes, they are. There were, Tom, could you talk more about that with the performance measurement plan?
Yes. So there were KPIs that were developed, and these have kind of moved from time. When we originally did the Easton area, the key performance indicators also included elements of carbon footprint and so on from these vehicles being electric. At present, the KPIs that we are really looking at now are more focused on, since this is a first last mile solution, on really kind of the numbers and the ability to satisfy the end user needs. And also if there is any increase in transit utilization based on these KPIs. So those are really the two that we're focused on. From a pure informative standpoint, and particularly the first deployment that was in the downtown region, that was more based around getting everybody's feet wet about how do you do procurement, how do you prepare the infrastructure for this, how do you operate and evaluate these types of situations. So we didn't really have performance indicators, but there was a great ability to capture a lot of good quantitative data on the performance of these vehicles and the use of them. And so that helped us decide and helped us with the second procurement as well. So while not a key performance indicator in the traditional sense, they were valuable insight into lessons learned for this.
Yeah, and I actually have some results from the survey that we did for the first deployment. So one of the questions we had asked was whether they had ever ridden in a self-driving vehicle before, and 90% had not, which honestly I thought that was actually lower than expected. So for 90% of people, this is their first time in a self-driving vehicle. And then we asked them how trusting they were in the technology, both before and after experiencing it. And I think 97%, almost everyone said they became either more trusting or their opinion remained unchanged to what it was before. And then I think around 80% of respondents said they valued having a human on board for oversight and to step in if necessary. And then we asked people if they would recommend trying the shuttle out to others, and almost everyone said yes. I think that was also around 95, 97%. So yeah,
Thank
those are
you.
mostly kind of about engagement, like Tom said, not performance measures, but just to get feedback.
Fantastic. This was one of the questions here, so
Oh,
thank
good.
you. Additional question. Next question, you might have already said it, mentioned it. Has there been a preliminary determination as to the cause of the accident? Was it an external factor such as fleeting obstruction, or was it an internal to the vehicle?
Tom, could you answer that question?
So the vehicle did exactly what it was designed to do, which was to stop when it detected a unknown state in terms of its situational awareness. So it did exactly as it was designed to perform. The conditions around what caused that, we can't go into a lot of details because that is still a discussion with the vendors and with NHTSA. But there is a plan to look to how to mitigate this in the future. That is kind of multiple fold. Not only is it just making customers aware of the potential of these vehicles to stop suddenly, but also a couple things about the route planning that could be altered that would eliminate this type of activity in the future. But I said the vehicle did exactly what it was designed to do. Unfortunately, the outcome was not as you would hope it to be.
Thank you. Next question. How do you deal with security certificates for SPAT messages?
So shuttles don't use SPAT in this case, but yeah, Tom, maybe you could talk about that more for the connected vehicle environment in general.
Sure. So the state of Ohio, under the organization known as Drive Ohio, has basically taken on the role here in the state to be the kind of the certificate manager with an outside party for certificates. So all of our connected vehicles that are in the city are utilizing that same certificate vendor for our purposes, and any in the state for that matter. You know, if the AVs had been deployed on a connected corridor, that too would have been the case. But I said, as Katie explained, we did not ultimately end up with that as a match as we originally hoped, just given how the needs and the technology drove us to finalizing the route that we had selected.
Thank you. We have another comment and a question. Feedback from the AV shuttle trial in Calgary showed that having a trial just for the sake of trialing the technology wasn't sustainable. Do you have a sense of how many of your passengers were using the shuttle for its intended purpose versus testing the technology?
Yeah, that's a good point and a good question. I think for our first deployment, you're right that part of the idea was to have it as a demonstration, especially considering that it traveled to the Smart Columbus Experience Center. And yeah, that wasn't a sustainable solution. It was good for the residents to see it for 1 year, but just given the cost, not something that you can be doing for much longer than that. However, there were a couple people who were using it for other purposes. For example, there are some parking facilities near downtown, and people were using the shuttles to travel from their cars to their jobs in downtown Columbus. For the second deployment, that one was a bit less of a demonstration. It's sort of why we did a two-phased approach, and the second deployment was more use case based. We weren't operating for too long, so I think a couple of the initial riders were probably there mostly just to see the technology and try it out. And it'll have to wait till longer term deployment to determine whether the people are actually using it in their daily commute or to get to some of the services that we are hoping to provide access to.
Thank you. We'll take the last question. What are your thoughts on shuttle progression to mixed traffic deployment? What barriers need to be overcome?
Yeah, so both of our shuttles actually did operate in mixed traffic, but there were some limitations. In particular, I mentioned before the speed. So, if they're going much lower than the general traffic speed, that can be frustrating to some other drivers on the roadway. To help mitigate that, we designed the route in a way that would avoid some of these higher speed streets, or at least streets that had more through traffic, stated on neighborhood roads where people are going slower generally, or they can take other routes if they want to avoid the route of the shuttle. Another challenge is at intersections, especially with the vehicle system not necessarily being able to both detect whether there are other vehicles there, as well as what their intention is. That's something that's even hard for humans. So I would say intersections are still a big challenge, as well as the speed. But in general, these vehicle systems, like, they can detect a lot of stuff. The vendors are very much trying to be as safe as possible.
Thank you. So looks like we're at the end of our webinar session. Please feel free to follow up directly with Katie via the contact details shown on the screen. Their additional questions will be answered directly by Katie in an email. And I would like to thank all attendees for joining today. And again, a big thank you, Katie and Tom, for your presentation today. Thank you.
Yeah, thank you too. Yeah, feel free to reach out if you have any other questions, and I hope you all have a great rest of your day.
Thank you.